In radical inequalities day 2, we're going to pick up where we left off yesterday, and so we're going to have to include the restriction on the domain. So I'm going to have two separate workspaces here, one for actually solving the inequality and the other for determining the restriction on the domain. From that, we will determine whether the restriction influences the solution to the problem. So over here, I'll write this, and in the restricted space, I will write the value underneath the inequality, the radical symbol. Remember, that will always be greater than or equal to 0 because the restriction occurs when the radical becomes negative. Remember, depending on the problem, there may be more than one or there may be no restriction at all. And also, depending on the way that the inequality is facing, the restriction may or may not play a part in the actual solution set that we're using. So our first step in the majority of these problems is going to be to square both sides. Number 3 and 4 below, as you can see, will be exceptions to that rule, and we'll address that when we get there. So in this problem, x must be less than or equal to 19. Over here, the restriction occurs when x is less than 3. So in our number line, we will determine if the restriction plays a part. At 19, we will put a closed circle. Because it's less than 19, it will be getting smaller. Eventually, it will hit the restriction of 3, which means that in this particular problem, it plays a part. The solution in interval notation is going to be 3 to 19 included. If you like set notation and have always liked set notation, there is nothing wrong with that. It will still be read the exact same way, and you just write it like this. I will simply be writing an interval notation because that is my preferred method of representing the solution set. Question number 2. So we'll go ahead and draw our restricted space. Additionally, we will include that restriction there. 8x plus 1 is greater than or equal to 0. Remember, that is always going to be true because the radical becomes undefined when the radicand, the part under the radical, is less than 0. Solving, we get 8x plus 1 greater than or equal to 49. Subtract 1 to both sides. 8x greater than or equal to 48. X greater than or equal to 6. Over here, so the restriction is when x is greater than or equal to negative 1 over 8. Or the restriction occurs when x is less than negative 1/8. Now we'll go ahead and graph this on here. 6 here, included, going to the right, and negative 1/8 is here. Notice that this will never go beyond the negative 1/8. Therefore, in this particular problem, although there is a restriction, it does not play a role in the solution set of this problem, which is going to be 6 to infinity included. The 6 is included, not infinity. Thank you. All right, notice the index of the radical. Because of the index of the radical being a 3, there is no restriction. Visual aid for you. The cubic root parent function looks like this. There is no beginning nor end. The important part about number 3, though, is that we do not have an isolated radical. Notice that when I put my parentheses around the radical symbol, there is a +7 on the same side. Please be observant of that and move that to the other side of the equation. Now this could be confusing because in previous lessons we went ahead and squared both sides before moving that. But remember, that was because we couldn't move the number without putting it on the same side as a radical symbol. That is different in this case because, of course, the 4 is by itself. The cubic root of x minus 6 is greater than negative 3. The cubic root. Let's write the right numbers in there. Now that it's isolated, I'll go ahead and get rid of the radical. Remember, the way to get rid of the radical is to raise it to the same index as, or the same number as the index. So that's going to be x minus 6 is greater than negative 27. Remember, that is still a negative number because I'm multiplying the negative 3 by itself 3 times. Negative times a negative is a positive, times another negative makes it negative again. Adding 6 to both sides. X is greater than negative 21. Because there is no restriction on this, I do not have to do anything more. The answer will be negative 21 through infinity, not included. Alright, in number 4, identify the square root again, so now we're back to that restriction. And we will be isolating the radical before squaring both sides. The square root of x minus 7 is less than 3. Square both sides. X minus 7 is less than 9. Add 7 to both sides. X is less than 16. So now that you're getting a little bit better at this, you can see that the restriction will play a role in this because it is less than 16. The number is getting smaller in the solution set, which means eventually it will. So our restriction, x minus 7 is greater than or equal to 0, is going to play a role in this particular problem. X must be greater than or equal to 7. Drawing our number line, we'll see what our solution set is. The open circle for the 16 because of the inequality. The closed circle for the 7 because it's the restriction. Therefore, the solution to this problem is 7 to 16, 7 included, 16 excluded. Question number 5. There is a restriction here. And because we're not sure which one is going to play the role of restrictor, we must start with both of them. Squaring both sides, solving for x, subtract your x's, add your 1, 2x greater than 6. Sorry, let's try our adding skills again, shall we? 8. X must be greater than 4. We're going to add 1 to both sides. 3x greater than or equal to 1, so x must be greater than or equal to 1/3. X must be greater than or equal to -7 as well. Now, originally, the problem states when is one greater than the other. Now you'll notice that because of the way the solution is presented, neither restriction plays a part. However, in future problems, it will. So I'm going to go ahead and address the situation as though the restrictions do play a part. So before we move on, I'll go ahead and give you the solution to this actual problem and then discuss how to find which restriction to actually include if it does play a role in the problem. So we're going to go ahead and make a hypothetical situation that says this inequality has been switched. Therefore, the answer is x is less than 4. Now you'll notice that there are two restrictions along the line. The restriction that it gets to first is the one that will be used, because beyond the number 1/3, part of the inequality is undefined. Therefore, the entire inequality is undefined. So in the future, when there are multiple restrictions in a single problem and they play a factor in determining the solution set, you will use the first restriction, whichever one is closer to your actual answer that you find in the problem. Okay? All right. All right, question number 6. We'll again isolate the radical. Square root of 9 minus 5x greater than or equal to 8. Square both sides. 9 minus 5x greater than or equal to 64. Subtract 9. Negative 5x greater than or equal to 55. Divide by negative 5. X is less than or equal to negative 11. Please note we made a sign change because we divided by a negative. The restriction. The restriction occurs 9 minus 5x must be greater than or equal to 0. Negative 5x greater than or equal to negative 9. Divide by negative 5. X is less than or equal to 9/5. So our solution, negative 11, occurs here. It goes to the left. Our restriction, 9/5, occurs here. It does not play a role in this problem. Please note when you divide by a negative, you must switch that symbol. That does not change. So negative infinity through negative 11 is the solution set to number 6. The following three problems, 7, 8, and 9, are yours to complete. Please have them ready tomorrow for class discussion, and let's make sure that we clearly understand what it is we're looking at when we try to solve these inequalities.